Hello, my name is Yami Ar, and this is a gameplay demonstration for Yami, my AR horror prototype developed for Android. In this video, I will show the core gameplay loop, work through the menu flow, and explain the key programming concepts and systems used to build the project. Yami is a AR game where players scan their environment to detect and capture reincarnated spirits. The prototype includes a complete menu system, email onboarding, event pop-up, 3 difficulty levels, and a working AR capture loop. The core idea is to blend AR foundation with atmospheric horror and a simple collectible progression system. Here is the menu. The UI design was inspired by Duel Links, Yu-Gi-Oh!, aiming for a clean and elegant and atmospheric style. Pressing New Game contains a hover button. Now I will proceed to demonstrate the transition. So we click on New Game, enter the email, click Submit. We can see that it's got the latest updates. It's very similar as Yu-Gi-Oh! Duel Links, that they show the latest updates and what the team has been working on. And it's got different buttons that it allows to see the different slides of updates. We press continue. Main event, it showcases the current event, what is happening basically, and also it kind of like states the DLC to encourage players to keep purchasing content from the game itself. We will press continue, and now we go to the menu of choose your difficulty. We got 3 difficulty options, which is Sane, Insane, and Madhouse. The player then will choose their desired difficulty. We will now demonstrate what is the Sane difficulty, and we will follow with Insane and Madhouse to demonstrate that we had achieved 3 different enemy behaviors and translated to the game as difficulties. Now that we enter AR gameplay, the AR game camera manager provides the light camera feed, and the AR foundation detects the environment. Once tracking begins, the ghost spawner places a ghost a few meters in front of the player. The ghost behaves differently based on the chosen difficulty. For example, for this particular case, Sane doesn't move. It's got a state of idle, which stays static. So when the player starts to rotate the camera, they see the ghost placed statically, and they are able to capture it. So once they tap on the ghost, this square acts as a reticle, and when it's aligned with the ghost, they proceed to capture it by tapping it. By tapping it, adds 20 points, because this specific spirit was worth 20 points. And a raycast was fired from the center of the AR camera, and when it hits the ghost collider, the capture succeeds. Spirit points, they were awarded, and the save manager writes the updated data to a JSON file. Now we will proceed to demonstrate the Insane difficulty mode. By pressing Insane, the ghost spawns. However, this time the ghost is not noticeably harder. The speed increases, the flicker chance, and it goes up, and the capture window becomes shorter. The ghost also performs small rush movements towards the player, creating more pressure. Difficulty mode. By pressing Madhouse, the ghost spawns. However, this is the most difficult gameplay mode. The ghost moves very fast, flickers aggressively, as we can see, it just spawns and disappears. And the capture window is extremely short. As we can see, when it spawns, we barely have any time to react. However, I managed to click fast. and he awarded me the points. For each of the difficulties, the points they're supposed to be a different range. However, for this demonstration, I decided to keep it simple, keep it on 20 points, to just demonstrate the different difficulty modes that I implemented in this game. This mode of Madhouse, at the moment for this MVP, it combines fast movement with sudden flicker disappearance, making aiming much harder. So now I will proceed to explain key programming concepts and a full difficulty system. One of the main foundations of Yami is the manager architecture, which I created by using central manager objects containing game manager, difficulty manager, save manager, and a UI manager. Each uses the singleton pattern, which ensures only one instance exists and can be accessed globally from any script, meaning that they communicate between them as they explain in class. The game manager controls the game state, spirit points, and communicates between systems. The UI manager handles all panels, transitions, and capture feedback. The save manager stores spirit points in a JSON file using application.persistent data path. The ghost spawner places ghosts in a AR space, and the ghost controller handles the movement and behavior using a sine wave motion. Now I will proceed to explain the difficulty manager, how we store these three set values. The ghost speed, flicker chance, capture window length, and optional aggression behavior. Sane mode uses a slow speed, very low flicker chance, and long capture window. Insane mode increases speed, flickering chance, and reduces the capture timing. Madhouse mode uses fast movement, very heavy flickering, aggressive rush behavior, and short capture window, as we could see before in the demonstration. These values are loaded in the ghost when the AR scene starts. For example, a speed equal difficulty manager dot instance dot current speed, as one of my codes says. This means that a single shot prefab can behave completely different depending on the difficulty. Movement speed affects how quickly the ghosts move toward the player. Flicker chance uses random checks to hide and show the ghost. The capture window uses a routine that opens and closes the capture state depending on the difficulty by applying a wait for seconds script. Wait for seconds state. Cross-platform and technical considerations are that Yami uses AR Foundation, which supports both AR Core and AR Kit. As I use a MacBook, I will need to switch between Android and the MacBook installation kit. However, for this final project, I set it up everything on Android. That was just only for testing purposes. The prototype focuses on Android. The core systems are cross-platform, and I enable Unity's input system in both modes for compatibility, and use a canvas scaler to ensure the UI consistency on different screen sizes. So as we could see previously in the demonstration, that when I press new game, the screen resolution is set up at 1980p times 1920p times 1080p, meaning that is standardized to a normal Android screen. However, is responsive, and it allows the players to use a different measure if their phone is bigger or smaller, and it adapts basically. Finally, I built the APK, uploaded the game to itch.io, and published the project to GitHub. The prototype demonstrated the complete game loop, difficulty scaling, saving system, AR integration. And thank you for watching this demonstration of Yami. This concludes with my prototype video.